So for today's lesson, we're going to be working with common logarithms. It's going to be important that you have access to a calculator for a lot of the work we do today, and we will talk about how we're going to use that. So a common log, first off, is something that has a 10 as the base. So you'll often see that as just something that's log, and then could be something like this, where we don't see that subscript of 10. We don't see any subscript. It's implied that it's a 10 there. And we've run into that into a few equations so far. And then we have the change of base formula that we will talk about in a few minutes. So first we're going to figure out how to just use the calculator to calculate common logs. So we're going to take our calculator and use the log button. So on my calculator, I am literally clicking the log button. And then for this first example, I'm going to type 6 and then equals. So this is going to give me a decimal that's going to keep going. But it says here we want to round to the nearest 10,000. So we want 4 numbers after the decimal point. So my answer here would be 0.7781. All right, we're going to go through and do the same thing. I'm going to do part B, so I'm going to just type log and then 0.35. So that will give me negative 0.4559. Next is log 7, and that's 0.8451. And then log 0.5 is going to give me negative 0.3010. Now you'll notice that each of these has this like squiggly equal sign next to it. So that means we're estimating. And we are estimating because we do have to round our answer. So it's not an exact answer, it is rounded. Now I will mention that if you are using the calculator that most of you have on your iPad or your, say, the iPhone, you are going to first have to type in what you want to take the log of. So for this example, I would have typed in 6, and then there is a button that has log base 10. It's next to the 4, and then click that and that will give you your 0.7781 for that first example. Okay, so just things are going in a little different order, but as long as you get used to your calculator, you'll be okay. So the next thing we're going to talk about is the change of base formula, and this is going to be helpful when we have things that we don't exactly have an easy way to work with right away. So we can use this formula to help us put things in a common log so that we are able to calculate and solve. And we'll eventually, once we practice with the change of base formula, we are going to put this into use in solving equations. So our rule here, if you look at this part right here, we will start with something that's log base something of something. So that A and N, pay attention to those. So we're going to rewrite that as log N and over log A. Now, this is an implied base 10. All right, so we don't need to write it. It is a common log. So if we don't write that base, that is what we have. All right, so you will see that here in these next examples. So to rewrite log base 3 of 11, we can use that as log base 10 of 11 over log base 10 of 3. All right, in the next example, log base 4 of 13 turns into log base 10 of 13 divided by log base 10 of 4. And now I said divided by this time because this is something that we are actually going to use to compute. We are going to end up calculating these values and dividing them out to get numbers that we will work with. All right, so right here we're just going to practice rewriting these logs and then dividing it out to get an actual decimal. So this will turn into log 140 over log 5. So remember that these are both common logs with a base of 10. So what I'm actually going to do is I'm going to, in my calculator, I can plug in log 140 divided by log 5. All right, so that will give me 3.0704. Now, again, if you are using, say, like the iPhone calculator or your iPad calculator, you might need to type these in into different pieces. So you might need to calculate the log for 140. So that would be 2.1461 divided by log base 5. So that's 0.69897. So I guess I'd round that to 90. All right, and then you just divide that out. So 2.1461 divided by 0.699, and that would give me a very, very similar answer. But because you had to round in this portion right here, it will give you a slightly different answer, and that's okay. So if you show your work, I'll know where that came from. So you'll get 3.0702. So again, very close, but because you had to round along the way, you had to round in those separate steps, your answer will be slightly different, and that's okay. All right, with the next problem, I'm going to rewrite this as log 8 over log 6. So again, I can type that right into the calculator. So log 8 divided by log 6. So that'll give me 1.1606. And again, I'll show you what you should get if you're using the process where you have to do it step by step. So log 8 will give me 0.9031 divided by log 6 is 0.7781. So I'm going to divide that out. And that will give me 1.1606. So that one came out to be exactly the same. All right, so again, we are going to use this idea in a few minutes. All right, so we are now going to start solving equations using these ideas. So what we're going to do is we're going to take our equations. We have 5 to the x equals 62. So what we're then going to do is we are now going to rewrite this as a logarithm. So remember we, in the past couple lessons, were writing from logarithmic form to exponential form? Well, now we're going to go in the opposite direction. So we're now going to write this as a log. So we have log base 5 of 62 equals x. So our goal, remember, in this kind of situation is we're solving to get x by itself. Well, it already is by itself on the right side, so we just need to figure out the value of this. So in order to do that, we're going to rewrite this using the change of base formula to get this into a common log. So I'm going to write log 62 over log 5 is equal to x. All right, and I'm going to divide that out. And that will give me 2.5643. All right, and that's equal to x. All right, and again, we want 4 numbers after the decimal point rounded. So just to recap what we did here. So this was our starting equation. We started here. All right, I got that from the problem. So we're going to rewrite in exponential form. Then we used our change of base formula. And then we just calculated it. All right, more examples. All right, so again, we're going to start with this equation. We're now going to write it in logarithmic form. So I have log base 3 of 15 equals x. All right, so now I'm going to rewrite the left side using that change of base formula, so we have them both as common logs. So I have log 15 over log 3 equals x. So I'm going to plug that in. And I get 2.46497, so that would round up to 50. All right, and that's, again, equal to x. All right, so we're going to do the same thing with the next problem. So again, we start with this equation, 6 to the x equals 42. So this is in exponential form. I'm going to rewrite it in logarithmic form. So I have log base 6 of 42 equals x. And then again, I'm going to use the change of base formula. So I have log 42 divided by log 6 equals x. And that will give me 2.0860 equals x. All right, so now we're going to get into some equations that are a little more, not complex, but a little more work to them. So what we want to do, our goal is to get whatever base we have with the exponents by itself on one side of the equation. So we want to isolate this piece right here. So in doing that, we want to either add or subtract or divide anything we can over to the other side. So I'm going to start by adding this 3 to both sides. So I have 13k minus 7 equals 62. Now I can rewrite this in my logarithmic form. Okay, so I have log base 13 of 62 equals k minus 7. We're going to use the same process, the same steps we took in the last problems. We're going to rewrite this in the change of base formula. So I have log 62 over log 13 equals, and the right side stays the same, k minus 7. All right, so what we're doing here is we're going to actually calculate this out. So we have log 62 divided by log 13, and that'll give me 1.6090, and that's still equal to k minus 7. All right, and then now we're just solving to get that variable by itself. So we're going to add 7 to both sides. We're going to end up with 8.6090 is equal to k. So all we're really doing here is we're embedding these ideas of logarithms using the exponential form to logarithmic form. So that change there. We're then using the change of base formula and calculating from there and embedding that into our algebraic equations. All right, this wasn't supposed to be here, but this is the answer that we should get. So let's give this one a try. Now you'll notice we have times negative 10 at the beginning of this. Again, we're trying to isolate whatever base we have with an exponent. So we want to get that by itself. So to do that, I'm going to start by dividing both sides by negative 10. So that's going to leave me with 7 to the 3 minus 6r equals 5.7. All right, from there, I'm going to rewrite this in logarithmic form. So I have log base 7 of 5.7 equals 3 minus 6r. All right, now I'm going to use my change of base formula. So I have log 5.7 divided by log 7 equals 3 minus 6r. All right, the left side, we're going to take care of that by using the calculator. And I'm going to get 0.8944 equals 3 minus 6r. All right, we're going to solve using our algebra from here. So I'm going to subtract 3 on both sides. And that'll give me negative 2.1056 equals negative 6r. And then we're going to divide both sides by negative 6. And that will give me 0.3509. So that's perfect, exactly where we should have ended up. All right, so again, we want to try to isolate on one side whatever base we have with an exponent on it. So in this first problem, we had to move that 3 over by adding it. In the second equation here, we had to divide by negative 10. So once we do that, then we're able to rewrite into logarithmic form, use our change of base formula, and then solve the algebra. All right, so we got one more problem here, and there's just one more extra step than what we looked at in the last problem. But I'm going to start by moving this 3 over. So again, like I told you in one of the last lessons, we always want to do any multiplication or division as our kind of our last step when we're moving things over, just so that we remember to multiply or divide things appropriately as needed. All right, so here we are. So we subtracted the 3 from 22, so we got 19. So now I'm going to divide both sides by 9. So I'm going to get 4 to the 2n plus 9 equals 2.1111 repeating. All right, so I'm going to now rewrite this in my logarithmic form. So I'm going to get log base 4 of 2.1111 equals 2n plus 9. All right, from here we're going to rewrite using our change of base formula. So I have log of 2.1111 divided by log base 4 equals 2n plus 9. And I'm going to compute the left side. So the left side will give me 0.5390 rounded equals 2n plus 9. So I'm going to subtract the 9 from both sides. So on the left, I'll have negative 8.461 equals 2n. Divide both sides by 2. And I'm going to get negative 4.2305 equals to n. All right. So again, to recap what we did. So you're solving here, moving things around to isolate the base with the exponent. All right, so that's what we did. We subtracted, we divided, and then we had our exponential form. So we rewrite in logarithmic form. So basically, what we're trying to do is get this into exponential form. We want to have this in the exponential setup so that we can rewrite this in logarithmic form. Then we use the change of base. Then we actually do our calculations. And we do the algebra. And if you can get that process down, you will be good to go.